Okay, so another common situation that kind of involves this repetition, this permutation idea, is pathway problems. So here we're in all these questions here, we're moving from a point to another point, and in this case, we're kind of limited by the way we can move. We always have to move closer to our destination, so I can't go back in a direction. So say I'm starting at A here, I want to go to B, I can go up all the way here, and then I can go all the way over to B. That makes sense. That's one way I can do that. I can go up, I can go over, I can go up, and then all the way over to B. So that's another way I can do that. Or I can go up, over, up, and over. So right now I've drawn 3 ways, but there's going to be a lot. So I can go over, up all the way, and then over. So there's another different path I can take. So there's a lot of different paths I can do here. And there's a few ways to solve this question. I'm only going to really show you the one way, the quick way to do this. Our last couple of optional lessons, we'll talk about the Pascal's triangle. You can technically use Pascal's triangle to do this kind of question. But maybe I'll show you a little bit of that to start off with here. So what I mean by, well, you'll see Pascal's triangle in a sec when the optionals, but I'll talk about some of the patterns we see here. So if I start at A, how many ways does it take me to get up to this spot here? There's only one way I can do it. I can't backtrack around here, so I can only go up to this point. So there's only one way to go there. And the same thing, I can only go one way to get to this point. But this point in between the two, these ones here, I can go this way, or I can go this way to that point. So there's 2 from there, okay? Now, if I wanted to go to this point that's right above this other one, there's only one way for me to do that, from A. You have to imagine it's coming from A. I can only go from A straight up to that point. So it's only 1. And the same thing over here, I can only go 1 over here. So all these, actually, I go from A to any of the outside edges, I can only go once, all the way out to the outside edges. Once, all the way out here, okay? Now, these other points over here, the ones that are not on the outside edges. So look at this point here. How many ways can I get to that point? Well, I could go up all the way into that point there. Okay, that's good. I can go over and up all the way to this point. Or I can go up, over, and up. So there's 3 ways to get that point. Now, how many ways can I get to the next point that's above it? Well, I'm going to pick up the next pen here. So I can go up all the way and over. I can go over, up all the way, up, over, up all the way, or up to and over, up all the way. Oh, 4 ways, okay? So obviously it's going to get a little bit trickier. It's going to get a little bit ugly. We're trying to find how many ways can I get to B. So to this point, it's 4, okay? If I follow the same logic as this other point here, this point is also 3, and this point here is also 4. Now this point here, how many ways can I get to that point? How many ways can I get? So this point right here. So there's 3 ways to get to this point, right? And then each one of those 3 ways can go one more step over here. So there's 3 ways from this direction, right? And then down here, there's 3 ways from this point to get to this point. And each of those 3 ways can go one more step to this way. So there's 3 from each direction. So this point is 6. So there's 6 ways. And you can actually draw all those out if you wanted to. There's 6 ways to get to this point. If I follow that logic to the next point above here, if there's 6 ways to get to this point, each one of those 6 pathways can go one step more. So there's 6 ways to go up more. And there's 4 ways to get to this path. So there's 4 ways to go that way. 4 more ways, sorry. So there's 10 to that one. So what I'm doing is I'm adding the 2 pathways that are connected to it. Remember, you can always move towards B. So you can see out of that 4, that was a 4 because it was 1 plus 3. This over here would be a 5 because that's 1 plus 4. This would be, to get this point here, this is going to be a 10. This is going to be a 15. This is going to be 20. My last one here is going to be 35. So there's 35 ways. So I'm just adding up this piece here. So to get that 35, I took the 20 plus the 50. So I'm adding those two things coming at each other, right? So you get 35. Now, yeah, this video is going to be a little bit longer, but I'm going to show you the shortcut way, and then we'll just use the shortcut way from now on because it gets a little bit tricky. Now, the shortcut way only works if you come to a point. If there's like holes in the graph, say there was a lake and you couldn't use this pathway here for some reason, then you have to do it this method. Well, all the questions we're going to ask in this course, we don't have lakes or trees or things in the way of our paths where some roads are cut off. We're always going to have coming to points. Like you see here, from A to C, that's a point. From C to B, they all come to one point. There's no like holes in the graph or weird funky shapes. They're all just continual rectangles. Okay? So the shortcut to this is thinking about this as a word. So if I want to go from A to B, what letters do I have? And you always have to go up 3 times, no matter what. So there's going to be 3 ups in there somewhere. So there's 3 U's in this word. And I always have to go right 4 times to get over to B. You can't go back, right? You can't go down, right? You always have to go up 3 times and right 4 times. So my word, 1, 2, 3, 4, 5, 6, 7, has 7 letters to it. But it doesn't matter. Well, the order does kind of matter. If I go up, right, 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 that's a different one than going up, right, up, or something like that. So the order does matter. So this is a permutation. But it doesn't matter which of those ups I do first. All those ups are the exact same up. So writing up, or up, or up, they're all the same. So it doesn't really matter. So I had to get rid of those repetitions of ups. So there's 3 U's and there's 4 R's. So I got to get rid of those as well. Now, if I did the math on this, I should get 35. All right, so let's double check that. So 7 factorial, big number, divided by 3 factorial, 4, let's do this one this way, factorial, 35. So there's 35 ways to do this. Perfect. Now, when it comes to a point like this, if I go A to C and C to B, you're just going to find both those and just multiply them. It's kind of the same logic we had finding those numbers that are in the previous one. They're just coming this way. So if I get to C, then from C, there's this many ways to get to B. So I'm just going to multiply those two. Okay. So in this one, I have up, right. And then this one I have up, right. So I'm just going to do both of them independent of each other. So from A to C, I have 6 ways. I had 6 paths I had to take. 3 ups, 4 or 3 rights, 6 factorial. Then I'm going to divide by, and then I'm going to divide by 3 factorial, because those are both being repeated that many times. 3 factorial, 6 times 6. I just happen to know those 2 numbers. So there's 20 ways to get from A to C. Okay? Then from C to B, there are 4 factorial divided by 2 factorial, 2 factorial. 6, that's 12 divided by 4. So it's only, no, it seems like there's more than 3 ways. Just 1 second. I think I messed up somewhere. Not 12, is it? My bad. Why was I thinking it was 12? I don't know. 24. That makes more sense. 24. 24 divided by that 6. Okay. So 6 ways. I could probably draw all 6 of those out. We almost did up here. Draw all 6 ways out. I could probably just do that. Actually, you can see that right here. That is this box. And there's 6 ways to get that top corner from A. Okay. Now, from A to C, there's 20 ways, and each of those 20 ways, there are 6 more ways to go to get to B. So I'm just going to go 20 times 6. So there are 120 ways. And you can do this by using the whole Pascal. This is what we call the Pascal triangle, where you're adding the 2 numbers to get the new number below. So you got to kind of flip it around sideways, but it is technically the Pascal's triangle. But you can do that all the way down to B. It gets a little bit trickier when you get to here. These numbers are not going to be 1s, they're going to be 20s. That's fine. Here's one. This one here is a little bit tricky. It looks like it's just going to be a nice big rectangle, but they have to go from A to C. You have to go to the C, and then from C to B, and always moving closer to your target. So there's actually these pieces you're not using, right? So you're just going from here to here. So it's just the same as question as the previous one. I want to go from A to C first. A to C. So there's 1, 2, 3, 4, 5, 6, 7. 7 factorial, 3 factorial, 4 factorial. Didn't we just do this one up here? Yeah. So there's 35 ways here. I'm not going to bother trying to do that again. And from C to B, there are 1, 2, 3, 4, 5, 6. And then there's 2 factorial, 4 factorial. Okay. What is this one? I'm going to have to just type this in my calculator here. So 6 factorial. Okay. Divided by 24 times, what was it? 24 times 2. Okay. So I'm just using the knowledge of 4 factorial, which we had to figure out up here. What does happen here? Didn't I fix that? I thought I fixed that. 4 factorial is 24 and 2. Honestly, I thought I did fix it. Maybe it just kind of reset itself. I got 15 here. So it's 15 there. Cool. And yeah. And what is 35 times 15? I don't know. What is it? 525 ways. That's a little bit unwieldy if I want to draw all those little arrows. A little too many. This is the same question here. A particular town has 8 streets that run north and south, and 6 streets. So if you wanted to draw, you could. You can go 1, 2, 3, 5, 6, 7, 8. So that's on that side. Then there's 6 running this way. 1, 2, 3, 5, 6. So there's a dot here. There's a dot here. 6. 1, 2, 6, 7, 8. Now, you could draw all the other streets in this. So this would be a nice little grid filling out this whole thing in here. How many different pathways if I'm going from the northeast to the southwest? If you always have to move closer, that's one of the restrictions here. You always have to move closer each time. How many ways can I get from there? What I've drawn here is only 2, but just imagine that there's a whole grid system in here, right? Continuing all the way down, right? I'm not going to draw it all out because really it's just going to be how many ways, one way and then down. I'm going to add those together. So 8 plus 6 factorial, and then divided by 8 factorial, 6 factorial. I have no idea why I drew so many brackets there. So I'm going to put my calculator on the other side so it doesn't get my way. So 8 plus 6 is 14. So 14 factorial, really big number, pretty close to being a number that I can't. It's times 10 to the 10. So it's getting close to the numbers that you can't actually do. So if you couldn't do it, you would have to kind of simplify this down and reduce it down a little bit. But we could actually do it this time, so that's fine. So remember, you could do that by simplifying them down. I'm just going to punch it the way it is in the calculator there, or the way it's written. So it's 3,003 ways. That looks good. Now, If I wanted to, I could do it this way. I can go 14 factorial, 8 factorial, 6 factorial, start reducing things down to see if I can simplify this. So 14, 13. What if my calculator doesn't have a factorial button? That could be a problem sometimes. You're stuck on a desert island. How would you do this without a calculator? Okay, so I'm going to read 8, 9, 10, 11, 12, 13, 14. Okay, so I'm going to expand that out. I'm going to cross that off there. 6, what is 6 factorial? 6 factorial. Does that reduce out with anything on the top there? 720. Yeah, not really. Okay, so I have 720. You probably could see what else crosses off here. Just like looking at this, I think 6 here, 20 times that. So that's going to cross off there. I got an extra 6 here. So it's a kind of get ugly. You can technically reduce this down and make it look a little bit nicer if you wanted to. I'm just having fun at this point. You could just stop the video at any point. Right. And that's what I think it reduces down to. You can reduce it down even more. Divide the top and bottom by 2s and 3s. And maybe I'll do that just for the fun of it. Because this is technically 3 times 2. Divide by 3. That'll end up being a 3 there. Divide by 2 and it'll be 7 there. 7 times 13 times 11 times 3. Let's see if that works. Yeah, we're done this lesson, so you could have just stopped at any point rather than watching me ramble on here a little bit. Hey, look at that. Ends up being the same number. 7 times. So reduce it down nicely. Cool. Checks out. All right. So the next lesson, which is a little bit shorter, you can see that literally it's just one page. We're going to just talk about permutations with cases. Yeah. This one just has a bunch of ors in there. We'll talk about that a little bit more. Okay. I'll see you then.